Hello viewers, in today's class we are going to discuss one important application of combinations, right? So here the problem is regarding the counting of the number of parallelograms formed by a set of parallel lines, right? So here first of all we'll take a particular problem related to the counting of number of parallelograms. Then we will generalize the problem, right? In other words, we can say that we'll derive the general formula for the given problem, right? So here the problem goes like this: how many parallelograms can be formed from a set of 4 parallel lines intersecting another set of 3 parallel lines, right? So here the problem says that if we have a set of 4 parallel lines, here I am drawing a rough diagram, and here we have a set of say 4 parallel lines, right? And these 4 parallel lines are intersected by a set of 3 parallel lines, right? So we can draw like this, and we have these 3 lines. So here we have 3 parallel lines, and here we have the 4 parallel lines. So the horizontal parallel lines are drawn by the green color, and the vertical parallel lines are drawn with black color, right? So now we have to find the total number of parallelograms formed when a set of 4 parallel lines intersected by another set of 3 parallel lines, right? So now let us mark the point of intersections as A, B, C, D. Then we can have E, F, G, H. Then we have I, J, K, and L, right? So these 4 parallel lines are intersected by these 3 parallel lines, and the point of intersection of the lines are denoted by the capital letters, and here we have to find the total number of parallelograms formed, right? So viewers, here we can see that we have one parallelogram as A, B, F, E, another E, F, E, F, J, I. Then we can have A, B, J, I, A. Then we can have B, C, G, F. But the way we are counting the number of parallelograms is not feasible, right? Or in other words, we can say that if we go on counting the number of parallelograms in such a way, then it is not practical, right? So what we will do here, so we have to find a formula for counting the number of parallelograms, right? So what we will do, we'll make use of the concept of combinations, right? So let us see how we can do this. Now see, here we have the set of 4 parallel lines. So let us denote the green lines by n, and here the value of n is given as 4, right? So the number of parallel lines are given as 4, and here the another set of parallel lines is given as 3. So let us denote it by m, and let us take the value of m as 3. So here these are the 3 parallel lines, right? So we have denoted the black lines by m and the green lines by n, right? Now here one important thing is that a parallelogram has 4 sides, right? See, we have a parallelogram like this, and it has 4 sides. Now we see that the opposite sides are parallel, and we see that in order to form a parallelogram, we need to have 4 sides, right? And here the parallelograms are formed by the intersection of the green lines and the uh, black lines, right? So see, if we take this parallelogram, for instance, if we take the parallelogram ABFE, then we see that this parallelogram has 2 sides which are of green color, right? And 2 sides are of uh, black color, right? Similarly, if we take the parallelogram, say BJ, BJKC, BJKC, then again we see that this side, that is BJ and CK, are of green color, and BC and JK are of black color, right? So we see that the parallelograms has 4 sides, and 2 sides are made up of the green color, and the 2 sides or the other 2 sides are made up of the black lines, right? Now let us come to the counting of the number of parallelograms. So here the number of parallelograms which are formed out of the intersection of these 4 green lines and the 3 black lines, right? And here we see that each parallelogram has 4 sides. Out of those 4 sides, 2 are of green color and 2 are of black color, right? So what we'll do, we'll take, see here the number of green lines are 4 and the number of black lines are 3, right? And each parallelogram has 2 green and 2 black lines, right? Or in other words, we can say that each parallelogram is made up of 4 sides. Out of those 4 sides, 2 green lines, or the 2 lines, come from these 4 horizontal parallel lines, and the other 2 black lines come from these 3 vertical parallel lines, right? So now what we will do, will select, or we have to choose 2 green lines out of these 4 green lines, right? And the number of ways to choose 2 straight lines out of these 4 straight lines is 4C2, right? And the other 2 sides of the parallelogram will be chosen from these 3 black lines, right? So the number of ways to choose 2 straight lines out of 3 black lines is given by 3C2, right? So now we have here 2 lines which are chosen from 4 green lines, and here also we have 2 lines chosen from 3 black lines, and thus we have 2 plus 2 4, and the parallelogram has 4 sides, right? And the total number of parallelograms would be then given by 4C2 times 3C2, right? And this 4C2 is 4 factorial over 2 factorial, 4 minus 2, 2 factorial. Here we have 3 factorial. This is 2 factorial, and 3 minus 2, 1 factorial, right? So here we have used the result, that is n factorial over r factorial and n minus r factorial, right? Now 4 factorial is 24, and here we have 2 times 2, 4, and 3 factorial is 6, and here we have 2, right? So this is 4 6 are 24, and here we have 2 3s are 6, so we have 3 times 6, that is 18, right? So the total number of parallelograms which would be formed by the intersection of these 4 parallel lines and these 3 parallel lines is given by 18. So the number of parallelograms would be 18, right? So now viewers, here will derive the general formula for calculating the number of parallelograms. Now viewers, let us consider the n parallel lines like this, right? In this case we had 4 parallel lines, and here we can take n parallel lines, right? And these n parallel lines are intersected by another set of say m parallel lines, right, like this. So suppose here we have m parallel lines, right? And as we have just seen that in order to calculate the total number of parallelograms formed when these n parallel lines are intersected by a set of another m parallel lines, what we have to do, we have to select 2 straight lines out of these n parallel lines, and the number of ways are nc2, right? And the another set of 2 straight lines which are to be selected from these vertical parallel lines are given by nc2, right? Because for each parallelogram we have 4 sides. 2 sides come from these n parallel lines, and the another 2 sides come from these m parallel lines, right? So we have nc2 and then we have mc2, and the total number of parallelograms are given by the product of these 2 quantities, that is nc2 times mc2, right? And nc2 is given by n factorial, this is 2 factorial, this is n minus 2 factorial, and here we have m factorial, here we have 2 factorial, then we have m minus 2 factorial, right? Now we can simplify these 2 terms. We can write n minus 1 and n minus 2 factorial. Then we have here 2 factorial is simply 2, and this is n minus 2 factorial, and here we have m minus 1 and m minus 2 factorial, and here we have 2, simply 2 factorial is 2, and here we have m minus 2 factorial, right? And these 2 get cancelled, these 2 get cancelled, and we are left with n minus 1 over 2 times m minus 1 over 2, right? So the final result is nm, we have n minus 1, m minus 1 over 4. So this is the general formula for calculating the total number of parallelograms when a set of n parallel lines are intersected by a set of another m parallel lines, right? And if we now apply this rule to this problem, then we have the value of n as 4, because we have 4 parallel lines here, and the value of m is 3. So if we substitute here, then we'll get 4 times 3, then we have 4 minus 1 is 3, then 3 minus 1 is 2 divided by 4, and 4 and 4 get cancelled, and we have 3 3s are 9, 2s are 18, right? And which is the same result which we have just calculated, right? So viewers, this is how we solve this problem. And here Always remember that when we have two sets of such lines, the parallelogram which are formed are made up of two different sets of straight lines. The one set of parallel lines comes from this set, and another set of parallel lines come from this set, and the general formula for calculating the total number of parallelograms is given by this formula, right?